This is the second part of our screencast covering caching using PostSharp. In this screencast, we're going to discuss how to use some of the more robust features of PostSharp to make our caching more customizable. So one thing that it makes sense to do is to add a configurable timeout value. Now, as we've discussed in earlier screencasts, the best way to do this in PostSharp is to pass it in as an argument to the constructor. So let's create the constructor. So we'll say public cache attribute. We'll take in an integer and we'll just call it timeout, and we'll need to assign that to an instance variable. We'll call it timeout as well. Private int and we'll say timeout equals timeout. Now we can use this timeout value in our onSuccess whenever we store the item in the cache. So now the cache attribute will only live as long as the timeout that was passed in via the constructor. Now, in order to use the cache timeout, we need to go back to the banking service where we have the cache attribute applied, and as you can see, we have this underline telling us that the object cannot be created, and it's because we don't have a default constructor anymore. We require that the timeout value be passed in. So let's just say 60 for now. Now, there are still more interesting things we can do. Let's go back to the cache attribute. To get the method name at compile time, let's first create a private instance variable. We'll call it method name, that will hold the name of the method, and in order to get it at compile time, we'll need to override the compile time initialize method and simply set method name equal to method dot name. Now down in our onEntry method, we can replace args.method.name, which uses reflection, with method name. So that'll reduce the resources that we have to use to get the method name by a little bit. Now, there are still more interesting things we can do with this. Let's say we want to check the return type of the method that this attribute is applied to ensure that it makes sense to be a cache. For instance, we wouldn't want a cache attribute to be applied to a void return type or even an iDisposable return type. So let's go ahead and implement that. So we'll say public override, and this time we're going to do compile time validate, and the first thing we need to do is get the method info. So we'll say method info equals, and we'll just call it info, equals method, and we just need to cast this to method info. Now we need to do our validation, where we're going to check the return type of the method info, or the execution method, to ensure that the return type is something that makes sense to cache. So we'll say if type of iDisposable dot is assignable from info dot return type, and we'll add a condition here, or type of iEnumerator dot is assignable from info dot return type, or type of void dot is assignable from info dot return type. Of course, you could add additional constraints checking the return type, but that should cover most of the bases for now. So if this is true, we want to send a warning message to the user to let them know that the attribute is inappropriately applied. So we can do that by saying message.write, and we'll want to say severity type dot warning. We'll say the error code is just caching attribute. the format is, we'll say caching cannot be applied to this method, and we'll have a format string there that will hold the method name. And then lastly, we just pass in the method name, so we'll say method.name. Now, in addition to providing the warning message, we also want to return false, which will indicate to the compiler that this method did not pass validation. Now, if the return type does not match one of the criteria that we specified, if it is not iDisposable, iEnumerator, or void return type, then we want the base compile time validate method to go ahead and execute. So let's test this. Let's go back to the banking service, and we'll create a few methods that we'll call that will be the return types that we specified earlier. So let's create one called public. It'll return iDisposable. It'll just be called getDisposable. And we'll have it return a new SQL connection. We'll create another method called getEnumerator, and it'll return iEnumerator. And we'll just have it return get all accounts dot get enumerator. And then lastly, we'll have a void return type, public void, and we'll call it get void, and it'll just return. Now let's go ahead and copy this cache attribute that we applied to get account earlier, and we'll attempt to apply it to get disposable, get enumerator, and get void. Now if we return to program, we'll specify calls to those methods that we just created to try to get them to cache the items. So we'll say bank service dot get disposable, bank service dot get enumerator, and bank service dot get void. So let's just try and build this and see what happens. So the build succeeded. If we go to our error list, we'll see that we have warnings that tell us that caching cannot be applied to this method: get disposable, get enumerator, and get void. But let's execute this anyway and see what happens. We'll go to cache attribute and we'll set breakpoints on the on entry and on success. Now we could put breakpoints in compile time validate, but they would not be executed because this method it's executed at compile time. And if we go back to banking service, we can apply breakpoints to get disposable, get enumerator, and get void. So let's F5 the application and see what happens. So the first thing that happened was that it went directly to the executing method, the get disposable. It never executed the on entry method as we saw earlier in the previous screencast. And if we let this continue, we should see that it does not hit the on success breakpoint either. So it just moved down to the next method in the execution chain, which was get enumerator, which is what we expected, and lastly get void. So the caching logic in the aspect was never applied, even though the caching attribute was applied to the method. Now caching has become so dangerously simple that somebody could go up at a class level and apply a cache attribute, and caching would attempt to be applied to every member of this class. But not every member makes sense to cache. For instance, you hardly would ever want to cache a constructor. So how can we guard against that? Let's go back to the cache attribute, and we can apply a multicast attribute usage at the top, the same that we would with standard attributes, that would guard the attribute to only be applied to methods. So if we say multicast attribute usage, and we say multicast targets dot, we'll see all of the available places where we could apply an attribute. So we could do it at a class level, constructor level, any member, but for our purposes we want to limit it to just methods. So we'll say multicast targets dot method. So now we can go back to the banking service and remove this attribute at the class level. Another interesting thing we can do is check for naming conventions to ensure that caching only gets applied to methods that begin with a certain name. So inside of the compile time validate, we'll add an additional check here. And we'll say if method dot name dot starts with, and we'll say get, and actually we need to add a not in front of this, so if the method name does not start with get, then we want to return false. So let's see this in action. If we go back to the banking service, so let's create a new method called save object, and it'll return an object. And we'll just return new object, and we'll attempt to apply the caching attribute here, and we'll say cache 60. So let's get this executing. Let's go back to the program, and we can remove these three because we've tested them and we're sure that they work, and we'll say bank service dot save object. So let's go back to the cache attribute, and we'll actually have this output a warning message as well. So we can copy the message from our return type check, and we'll just change the warning message. We'll say caching can only be applied to methods that start with get, and we'll output the method name. So if we go back to program and we try to build this, and we look in our error list, we'll see that caching can only be applied to methods that start with get, and it says save object. So we know that this will not execute the caching logic that we put in the cache attribute, but let's run it and verify that anyway. So we should still have our breakpoint set at the cache attribute. We have just set a breakpoint at save object, so let's run this and see what happens. So save object hit first, and the breakpoints that were on the onEntry and onSuccess methods will never execute, just as we expected. Now there's actually a more robust way to apply naming conventions at an assembly level even, but we'll cover that in a later screencast. Hope you enjoyed. Be sure to check out sharpcrafters.com for more information.